please. Good afternoon, dear participants of the conference. I am Andrii Romaniv from Pistrigach Institute for Applied Problems of Mechanics and Mathematics, NAS of Ukraine. The topic of my report on the screen, reduction of invertible matrices to simple forms and their application. Let R be a commutative elementary divisor domain. Oleg Mykolaievich spoke about this ring because denoted by Mn of R and Jln of R, the ring and the complete linear group of an order matrices over R. And let the matrix A over R. For matrix A, there exist invertible matrix PA and QA. These matrices are called left and right transforming matrix and reduction the matrix A to the Smith forms phi. The elements phi1 and phi(n) are called an invariant factors of the matrix A. Denoted by PA, the set of all less transforming matrix for matrix A. According to now results, for this set, there are equality holds. Where G the set of invertible matrix such that the product H by phi is equal phi by H1, where H1 is so invertible matrix. The set G was introduced by Zelisko for polynomial matrices and by Stedrick for matrix over commutative elementary divisor domains.
What is F here? What is F? Yeah. F. I see. Yeah, thanks.
This set is a multiplicative group or Zelisko group and consists of all invertible matrices of the next form. Invertible matrix and their representation as product of several factors with given properties played an important role in the study of many matrix problems. One of them is the multiplicativity of Smith normal form. In general, the Smith normal form does not have the properties of multiplicativity. For example, consider the matrix A and matrix B. This matrix has the Smith forms diagonal matrix 1, 2. The product of matrix A and B is the diagonal matrix 2, 2, in which is also the Smith normal form of this product, but the product Smith forms matrix is the matrix diag 1, 4. But under certain conditions, the Smith normal form is multiplicativity. Newman showed over principal ideal domain that this holds if the matrices have relativity prime determinants. Petrechkovich established a class of matrix over polynomial kings, principal ideal rings, and adequate rings, for which the Smith normal form has the property of multiplicativity. Stedrick indicated the condition for the multiplicativity of Smith forms over elementary divisor domains. He showed that invertible matrices can be written as the product of two matrices from the Zelisko groups. Next theorem. We see that this matrix is invertible and it equal the product of matrix L and H, where L and H is matrix from the Lisco groups. From the above example, it follows that not every invertible matrix can be expressed as product of matrix from the Lisco groups. We have the next questions. Under what condition can invertible matrix be representative in product matrix from the group the Lisco, and to what simple forms can invertible matrix be reduced by left and right transformation from these groups? For studying the Smith normal form of greatest common divisor and least common multipliers, we use the decomposition invertible matrix in the product of two matrices from group Zeliska. We have the next results. Let A and B the matrix non-singular second order matrix, and this matrix have the Smith forms phi and psi. Then the invertible matrix can be written in the form in the next form if and only if the greatest common divisor of these elements divides the element S. Later, Stedrick extended this result to arbitrarily second-order matrices over commutative Bezout domain of stable range 1.5. Moreover, Stedrick applied this result to the study of the adequacy of the non-singular matrix of second order. Let R be a commutative Bezout domain of stable range 1.5. This ring was introduced by Stedrick in this article definition. A ring R has a stable rank 1.5 if for every 12 of left relatively prime elements A, B, and C, where element C is not equal 0, there exists the element R such that the element A plus B, R, and C are left relatively prime. And the next definition is a definition about stable ranks of rings. This definition was introduced by Bass. Stedrick showed that these rings is elementary divisor rings. Consider the group of lower unitriangular n-order matrix over R and the said matrix of the next form. Theorem. Let R be commutative Bezout domain and phi non-singular D matrix. The following condition equivalent. The ring R has a stable rank 1.5 and the invertible matrix can be a reduction on the product 3 matrix lower unitriangular, the matrix on this form, and the matrix from group Zeliska. The next result, we showed the simple form of invertible matrices. Let R be a commutative Bezout domain of stable range 1.5. Then exists matrix H and L such that we have the next form. This form is not canonical with respect to transformation from this group. Example. Consider the matrix Psi and matrix Phi and invertible matrix S. This matrix S has already has the form 2. But in the groups exist the matrix H of the form and the matrix L of the form, such that the matrix S have the next simple form. But when we consider the triangular matrices, this form was canonical. In the study of Smith forms of greatest common divisor and least common multiplier, we use the decomposition invertible matrix as a product of elements from generating set. Consider the equality, where matrix B has a diagonal form. Consider the set of matrix where matrix L is invertible matrix and matrix L1 is not invertible matrix. This set was introduced by Stadrik and it is called a generating set. The elements of the set are all invertible matrix of the form. For non-singular matrix of the second order, we obtained the next result. Matrix S can be decomposition in the product of two matrices from generating group if and only if these elements divided the element S. Consider the matrix A and B arbitrary order and which have the next Smith form. And consider the diagonal matrix omega. Then it order 2 this equal is hold where LA and LB from generating set. It is necessary or sufficient that the element divide the greatest common divisor elements from invertible matrix S. Based on the obtained results for non-singular matrix of arbitrary order and under certain restriction of the invariant factors, the relationships between the common right multiplets are indicated. Theorem 3. Consider the matrix A, B, M, and T, which have the following Smith forms: phi, psi, omega, and gamma. And let matrix M and T are the common right multiplier matrix A and B. Then if the next condition are hold, the matrix M is a left divisor of the matrix T. Thank you for your attention.
Thank you. And thank you for your report.